Hello, data people. So, it's Jonathan here, and just scheduled this like midnight last night, so we'll see how many people actually join for this today. But if you are joining now, if you could please type in a little message in chat, it'll be great to find out what you are looking to learn. Obviously, things like data analytics, data science are huge, massive subjects. And there's lots of different people starting at lots of different points. So if you could type something in chat, that would be really helpful for me to be able to help you more as well. So if you're joining, type something in, that'd be great. So I'm also not sitting here talking to myself as well. I'd really like to be able to get some good engagement on these videos, so that can make it more of a conversation rather than just me talking. So also as well, if you're coming on, let me know what tools that you're currently using, at least what tools that you're using most of the time. For example, are you, well, maybe you know R, but you're still using Excel like maybe 70% of the time. You know, that's going to be like a very different conversation if you are, say, a regular R user and you're maybe looking for some tips on how to just use it more efficiently, more effectively. You know, are you a Python user looking to find out, you know, maybe some more tips and tricks, maybe a little bit more about R, different things like that. It would be really great to get some feedback from you guys. Okay. So, hey, Hendrik. Good to see you there. Thanks for dropping a message in chat. Really helps a lot. Really good to know that I'm just not talking to myself. Hope you're having a fantastic new year. And yeah. Okay. So, anybody else that we have here? Just drop in a line, so don't make this live stream too short. Okay. Hey, Julian. Good to see you too. Okay. Okay, great to have you guys on the line. So I came up with a few examples today. Now, I know, yep, really interested in the Flex dashboard stuff. Fantastic. Yeah, no, Flex dashboards are great. Really good way to develop web pages. And adding filters. Okay. Yep. Good stuff. Also, I think we've just had a few more people join. So if you have just joined, please drop a message in chat. Let us know where you're coming from, what your learning goals are, what kind of tools that you are currently predominantly using for your work. It really helps out just to make all of this a little bit more relevant. I had like a whole bunch of things that I was thinking of talking about today, but yeah, the more feedback I can get, the better I can direct the conversation and make it more useful, more relevant to everybody. Okay. So, we've had one question about Flex dashboards. I guess I've put up quite a bit about Flex dashboards lately. I don't know if there's any questions in particular that people have about Flex dashboards, or another question, actually, if you're jumping online, you can just type a quick yes or no. has everybody actually used Flex dashboards or even know what they are? That would also really help for this conversation as well. But just a couple minute overview of what Flex dashboards actually are. So sometimes you hear about people talking, say, if you want to publish your work, then you have a bunch of different options. I mean, you got these 3 different options up here. You've got Excel, you've got R, and you've got Python, right? So if you are using something like Excel, one of the benefits of Excel is that it's like this easy distributable format where you can build interactive models, right? So you can make models where people can plug in input drivers which affect the model, and they get the results straight away. So it's very interactive that way. When you go over to things like Python, well, I guess one of the benefits is that you could actually build an application out of what you're doing. Although these days, desktop applications are a lot less common. These days, you would move to something more like a web application, right? And the benefit of, say, something like a web application over something like an Excel model is that, well, it's much more scalable. It works anywhere across the internet. You have an internet connection, or it'll work on your intranet if you don't want to publish it to the kind of public internet. And it's universally will work in anybody's web browser, right? So those are some of the benefits of building a web application over sort of an Excel based model. Now, here's the thing with something like Python. If you want to build a web application in Python, well, you do actually have a whole bunch of different web frameworks, right? So you've got Flask and you've got Django for doing all that kind of thing. But those are basically some frameworks where you're kind of using Python in the back end, and you're still effectively using HTML and JavaScript in the front end, right? And so you're having to learn quite a few different things, and there's quite a bit of work actually involved for actually being able to generate a web page or web application, right? You're having to learn lots of different languages and frameworks. And the Flask and Django and everything like that, they're basically built for, well, web developers, right? Now, back in the day, like ages ago, my first job out of university was actually a web developer, right? So I guess I was what you'd call now like a full stack web developer for a little period of time. Back in the days when, it was much easier, much simpler than it is today. It is much, much more complex to build web applications these days because we've got things like, you have to learn concepts like asynchronous programming, right? So the client side talks to the server side asynchronously, right? And so messages being passed back and forth without having to like reload pages and all this kind of thing. And it adds quite a lot more complexity to the way that applications actually work, but it makes it more responsive as well, right? Now, this is where kind of R comes into the picture, and Flex dashboards, which was the thing that Julian was asking about earlier. So one of the benefits of something like Flex dashboards is that you don't need to know any HTML, you don't need to learn any JavaScript, you don't have to implement any asynchronous programming yourself. It just does it all for you, right? So, if you just have some R analysis already, like if you're already using your R for your analysis, and in a minute we'll go over some of the benefits of actually using R for some of your analysis as well. You can basically just use a markdown document and it will automatically render into a dashboard for you using something like Flex dashboards. And you can also render it to like websites, books, PDFs, whatever, right? Slides, all kinds of things. So there's a huge benefit of using something like Flex dashboards, which is effectively an R markdown document, it's called R markdown, by the way, but because it was implemented by originally for R, but actually it works with all the different languages as well. So even if you're a Python user, it's quite cool. You can actually use R markdown for actually pulling Python code into your Markdown documents and being able to render it into like all of these different formats, which is pretty fantastic. Another thing that I will say, so I don't know if is anybody here actually a Python user or has used Python before for anything? If so, just drop a little message in chat. That would be really useful to see. But anyway, if you have used Python for anything, there's a good chance that you would have seen Jupyter Notebooks, right? Because that seems to be the way that everybody's teaching Python these days, is Jupyter Notebooks. So if you have used Jupyter Notebooks, then our Markdown is kind of similar to Jupyter Notebooks, but it's a little bit different as well. Right, so the thing is with Jupyter Notebooks, and maybe I should have loaded up one here somewhere, but with Jupyter Notebooks, one of the maybe I will pull one up actually. So anyway, one of the benefits of Jupyter Notebooks is everything is in line. So you've got code and documentation all embedded within the same document, right? So you can, let's see. Right, okay, so the Jupyter Notebook looks something like this. And you can start typing some comments in here, and you type some code in here as well, and you can publish this as an HTML file or a PDF or something like that, and kind of send it off to people, and it's kind of interactive code at the same time, right? Now with our Markdown, well, Jupyter Notebooks, the thing is with them is that they always look like a Jupyter Notebook, right? Whereas our Markdown, you can render it to all these different formats as well. So it's not stuck in a notebook format, even if you want it as a notebook as well, right? Just try not to do too much here so I don't mess up some of the other examples I've already got set up. Okay. So, anyway, a few things I wanted to talk about when looking at data. But actually, is anybody here like predominantly an Excel user? I'm just wondering. Quick yes or no would be really helpful. So, I mean, I guess this some of this stuff will be pretty useful, I guess, even if even if you're maybe already an R user already, but you've come from a sort of Excel sort of background. I think there's certain things that if you've predominantly used Excel, you just tend not to look at, right? So, these days there's people from all kinds of different backgrounds getting into things like data analytics and data science and everything. Some people coming from sort of Excel, working with data backgrounds, some people coming from databases, some people from programmers, some people from statistics. And I think that if you come from any of these backgrounds, there's going to be something that you're going to be able to bring to the table, which is kind of the good thing, right? But I think that at the same time, how much there is this question of how much of each skill that you actually need to learn to be able to really effectively look at your data in a productive and safe kind of way as well. Okay. So I'm going to give this. So I teach mostly Excel and R. And one of the reasons why I like to teach some Excel is because it's a good way to get started. So, I mean, I was actually predominantly an Excel user myself for a very, very long time. Until I discovered R, and then it's like I now use R predominantly for probably 90% of my work or so. So, and I'm hoping that because of that background, I can give a little bit more insight to Excel users or people who have come from that background, you know, what you should be really looking out for, and why you might even want to make the switch in the first place. Just because, you know, even if you have made the switch, sometimes it's not always obvious. There's certain concepts that you just would have never really dealt with in Excel. So we will go over some of those. Now, under the data tab in Excel, we've got this option here called Get Data. And this gives you access to everything in Power Query. And Power Query is the kind of main thing I teach in Excel. And the reason for that, you know, sometimes people think it's this kind of handy data transformation thing and everything like that. But actually, one of the reasons I teach Power Query in Excel, and I'm just going to show some cool things here. So you can actually, say, merge a whole bunch of files from a bunch of different folders. And I'm just going to grab a folder here. Let's grab these files to merge. So I've got all these files here, and I'm basically going to click Combine. Right, so we get this little screen here. We've got combined files. We've got a sample from the first file. It's got data type detection here. Okay, I'm going to click OK. Okay. Okay, and this is the main Power Query editor here. So I don't know, has everybody actually used Power Query before or know of it? As you can see, you've got a whole bunch of transformation steps here. You've got all these things like removing rows, splitting columns, changing data types, adding columns, all these different things. And you've got all the steps down the side here as well. So they're all recorded. So in some ways, a little bit like recording a macro in VBA, but this is actually much, much better, right? And the reason why this is better is because VBA generally works on the sheet, like range A1, you know, it's not actually working on things like named columns. It's not actually working on the data, it's working on the elements of a sheet. So if anything moves, gets out of shape or anything like that, it's really not as robust, where this is much more robust. Okay, anyway, I'm going to load all this data. And the other thing about it is, so all the steps are, so it keeps history. It basically saves all your steps. And so if you ever swap out the data file, you can hit the refresh button, and then it's going to reload all of your data for you. So here we have this file here, and it's merged all of these different files. Okay, and we can see here that this has got 14 14 columns, including the source name. If we want to understand this data a little bit better, well, we can click on some of these things here. You've got some summary stats at the bottom here. So you've got an average, you got a count, you've got a min, max, sum. If you right click in this area, I don't know if you know about this, but if you right click on this area, you've got a bunch of different options as well that you can kind of add to these. Like you could add this count as well. And yeah, but you know, there's certain things that it's missing here. For instance, well, you've got the average or the mean, like you'd say in statistics, but it's missing things like the median. You can't really see the distribution of the data, and you can't see, you basically can't see stuff like the standard deviation and, you know, standard error and all these kind of different kind of things, which start to become actually quite useful and actually quite important for looking at your data. So I was talking with a friend the other day, and we're just having this conversation and saying, well, when you're working with data, what would you say are the kind of most important things that people should kind of be looking out for when actually starting to look at these kind of things? It's like, well, okay, one of the dangers is that when you summarize data, a lot of times when you're working in something like Excel, you know, maybe you use a pivot table or something like that, you're using very, very high level summary statistics, right? So maybe you're just using a sum, or maybe you're just using average. And when you do that without understanding the distribution of the data, then what can end up happening is that you know, that summary statistic might not actually make a lot of sense, right? So, I mean, this particular data set here, this is you know, this is basically a list of government employees, and we have some salary data for them as well. Now, the thing with salary data is that it's well, it's not normally distributed, right? And so this applies generally if you're looking at salary data. But actually, there's something to keep in mind when looking at most data as well. There's a lot of times we make these assumptions about that, you know, maybe that we do have like some sort of normal distribution or something like that. But normally, most of the time, data is positively skewed, right? Because, well, things are kind of limited at zero, whereas they can go up to kind of quite high amounts, right? So, and that's something that affects quite a lot of different types of data types, but in particular, salaries, they are highly positively skewed, right? So the averages are much higher than the medians, right? So something to kind of keep in mind there. Okay. Well, let's take a look at how we would do this kind of same process in R, maybe some of the benefits of it. And let me pull up R. Okay. So here in R, you know, we don't have this sort of super friendly point and click interface like we do in Power Query, but really it's not too bad either. So first up, I'm going to load tidyverse, and I'm just wondering, does anybody not know what tidyverse is? Just curious. If you don't, drop a little message. That would be really helpful. Okay. So I guess one of the things which is a little bit different about the way I teach R is that I very closely follow the tidyverse methodology for pretty much everything. And that gives it a much more kind of consistent way to use the language. And generally speaking, tidyverse is the kind of latest recommended standard for using things. But one of the reasons why I wanted to start doing some teaching actually is because I didn't really see a lot of lessons or lectures out there actually using this methodology. So if you're going off later on, so if you're not using R right now, then I would definitely be looking to follow the tidyverse methodology rather than just because if you look up a whole bunch of videos on YouTube, there's a lot of different standards that are being used, and that can actually end up being a little bit confusing, right? But anyway, this line here, I just run this. So what this is this is saying files is equal to, if you used a bit of DOS before, then, you know, like there's a directory. I'm looking at the data directory. I'm getting all the CSV files. This is going into all the folders, right? Because this actually has, should have shown this as well, but this has actually got a whole bunch of subfolders here, right? So it actually looks like this. So it's actually going into each file and grabbing the folders, the file out of each folder as well. And it's showing the full path there, right? So if I look at the list of files, then I have them all here, right? And this line here is basically going to merge them all. So if I do that, okay, then, okay, I have all of these files here. Okay, so that's just merge all these different tables. Now, there's a few things that you notice here. So this is effectively the same data set as I loaded into Power Query just a little bit earlier. There is one additional column here, right? So there's a higher date column, right? So back in Excel, right, we're missing that higher date column, right? And the reason for that is because in Power Query, effectively what happened is that the column specification was taken from the first file, right? Now, this higher date here is actually only in the last file, right? So it's only in this file here. Now, often what happens when you are when you're merging lots of different files, people tend to let's say you send this out to a bunch of people for some data collection, or maybe you're just getting it from different systems to maybe the snapshots that you've taken at different times, right? Maybe you have new data, you've got new columns that don't apply to all the files, right? So the fact that this is kind of tacked this on is actually quite handy. Now, the other thing is that when you're dealing with data, and sometimes maybe one of these files is not quite right? Or maybe one of these files is a little bit different. What if you don't necessarily want to merge all of these into a single table? What if you want to explore each table individually, right? So let me show you how you can do that, right? So here, I'm going to set up so in Excel, we have tables, right? So, which have got rows and columns, right? In R, you have something known as a tibble or a data frame. So a tibble or a data frame is basically a table, right? It's just a kind of different name for it. So I'm going to set up, I'm going to say file is equal to files, right? And what I'm going to do here is I'm going to say data is equal to, actually just wondering if, yeah, no, I'll do this actually. So okay. Actually, what I'm going to do is I'm going to take that instead, drop this in here. Okay. So let me just quickly explain what I've just done here. Okay. So inside of Excel, we are used to things like, well, you've got cells, right? You've got ranges, and then you have things like tables, right? Now, tables add a little bit more structure because we have named columns, right? And each column contains certain types of data, right? Generally, when we are doing data analysis, we want to look at structured types of data, right? So we want to, actually, I'm sorry. So when we want to have tidy data, right? Which basically means each column contains a single type of data, and each row represents a individual observation or an individual record. Now, if you've ever worked with databases, this is somewhat enforced. Now, this is, I would say, the good thing and the bad thing about Excel is that these types of rules, which make it relatively easy for working with data, are not very strictly enforced within Excel, especially before using things like tables and Power Query and stuff like that. If you just have data in sort of random cells, like even if I took all this data here, and say, let me select all that, and let's say I did a copy paste special values into sheet 1, right? Notice how this has lost all the table formatting, right? So this is really not very kind of strict or very structured at all. This has, okay. Now, in okay, in R, we have the fundamental building block of R. In Excel, the fundamental building block, I guess, is effectively a cell, right? So a single value cell, right? In R, the fundamental building block is something called a vector, right? And what exactly is a vector exactly anyway? A vector is a bit like one of these columns, really. So in R, each of these columns would be a vector, right? Now, the rules for a vector is that it can only contain one data type, right? And it'll have a name. So this could be head count, and it'll have a bunch of values. You know, we'll have annual bonus, and this will have a bunch of values. And so a table, or a data frame, as you would call it in R, or is basically inside of it. Now, why does that kind of matter? Why do you kind of care? Because everything in R is basically designed to work on these things. And so I know you mentioned you use Power Query. So because if you have used things like VBA or any other kind of programming language for that matter, you're probably familiar with things like loops and being able to basically perform operations on lots of different things with just typing a few commands. Now, effectively in R, everything is based on vectors, and so everything, all the tables inside this, a very nice, quick, and easy way to see what all these things are doing. If I wanted to merge like all of these at the same time, effectively what I would do is pick this out here, and let's see. And I could unnest this, right? And now I've got one big table, right? So the first column there is my file name. I have basically a lot more options as well. Because one of the benefits is really being able to work with multiple tables, almost just about as easily as you could work with one table, right? So before I was mentioning about some of the summary statistics. So there is a function called summary, right? Or I could type that in there. Actually, summary, right? So here we've got things like the the median, mean for every column, right? That's all kind of summarized for you all in one go. Let me show you a few other things as well. Okay, so here's a cool little thing in R when you go to actually view your tables, is that you've got this little distribution here. So as I mentioned here, that salary is very positively skewed, right? So in a normal distribution, you'd see this go up and then down like this, and you basically your bell-shaped curve, right? As you can see here, will increase the averages, right? So right, this one's a year column, so yeah, you can see that that's pretty flat. But again, these are kind of all the things that are really good, a really good idea to be looking at, so you understand actually what your data actually looks like, because maybe the statistic that you're applying to it doesn't actually make sense, right? So just something to keep in mind there. Okay. So what else could you do with this? So as mentioned, let me try and think of a good example. So I ran the summaries for one table. What was I going to do? I was going to run the summaries for all the tables all at the same time, right? So to do that, I could do something like that's okay. This little command here, map. This is a really powerful function in R. Actually, what it's basically doing is saying for every file, do this operation, right? And then so we had a list of files, and this will read in all of the files, right? And this part here, df is short for data frame. And as mentioned, the data frame is a table, which means it takes all these files and returns it as a single table, right? So it does all that work for you. If I just type in map, the default way that the data is returned is in something called a list. And what is a list exactly anyway? Well, a list is basically this thing here. So this column here is a list of tables, right? So a list can contain sort of any type of value, right? So here we have a whole bunch of tables, right? So now I've changed this into so you can see here, large list. It's got seven elements, and now I can just do a whole bunch of things with these. So let's say I wanted to do merged tables, and I wanted to do map summary, right? Okay, let me do that again. Okay, so that summary that we had before for one table, it's just done it for all of the tables, right? So you can kind of do that all in one go, right? And this is where this becomes really powerful. Let's say I wanted to do something else. Okay. So I've got dt, which is still that. Okay, let's call this Okay, so question, is map the same as lapply? When you use, would you use one of, when would you use one over the other? So yes, map is very similar to lapply. So lapply is list apply. Lapply is something that comes with base R. And the short of it is that I always use map, right? So I don't use I don't use the kind of base R functions for, well, that do the same kind of things, right? So some of the benefits of map over lapply is that when you use map, let me just type in here. So when you use things like map, you've got all of these different kind of parameters that kind of go with it as well. So all of these here, like map character, map double, map df, map, these all return your data in a different way and the way that you specify it, right? So lapply returns a list, right? Map returns it lots and lots of different ways, right? And it's a nice shortcut that stops you from having to do, if you want to do it just like lapply, you just use map, right? But if you want to return it as a list and then combine it all together into a single table, well, you can do that with lapply, but then you'd have to do lapply and then you would have to put it into, say, bind rows, right? So then you'd have to use two functions, what you could basically do in one, right? And you know, sometimes, so for instance, you've got things like map character, right? So this returns a character vector, right? Now, to do this with base R, that would not be lapply, that would probably be sapply, right? Which simplifies it. But then you're not guaranteed to get a character vector back, right? Map with like map double, map character, it guarantees the return type, which is actually really useful as well. So that is some of the benefits of map over the apply functions. But yeah, great question. Something slightly more technical, especially, you know, for those of you who haven't used R before. But this is why I teach pretty much exclusively tidyverse, right? Every now and then I'll introduce like a little bit in here or there, but a lot of the other training I've seen around uses a lot of base R, especially the more kind of academic courses. They're still using base R because that's what they were using 20 years ago, right? So anyway, there you go. Okay. So what are some of the other things that you could do with this? Let's do a few more functions here. Again, let's use some more map. So I could do something like what would be cool? So let's do a map if, and let's do a map if is character, and if the column is a character column, then let's get all the unique items for it. Right. Okay, so that's done that. And then this gotten returned a little bit too much data. Let's try map if is numeric. And then I'll use something like, say, quantile. Right. So there we go. We've got you know, all the quantiles done for all the numeric columns. And then if I pipe that into this as well, then I've got all the numeric columns converted to quantiles, and I've got all the character columns converted to unique values. Right. Maybe that list is a little bit too long for this. So let's do something different. Let's say there we go. Okay, so this is just getting the top 6 items for each one. Okay, and we haven't dealt with the date column there. But anyway, kind of some of the things that you can do quite powerfully. So you can manipulate columns very quickly, very easily across pretty large data sets. As you notice here, that this is 117,000 rows in here, but in our this, so my computer here, I've got a 16 gig laptop. I can probably load up between 5 to 10 million records of data without too much of a problem. So this is where it starts to have a lot more capacity than something like Excel. Now, you could argue that, well, Excel has things like Power Pivot, where you could also load up lots of data as well, past the sort of usual million sort of limitation that you have just in the sheets. But then you have to start learning DAX and stuff, so you can't really use Excel. It's not very well, I wouldn't say it's even really that well integrated with Excel, so it's almost another thing that you need to learn anyway. So I generally wouldn't bother with it. This is got a ton of features for being able to manipulate your data very quickly. Okay. Any questions about any of that so far? Anyway, so I guess the thing is that it's able to work with bigger data sets than Excel. 2, it's able to work with, it's able to do mass operations much more effectively as well. Here's another little, say, mass operation. Let's say we wanted to do something like, what is this data set got anyway? Say, let's group by, I can just hit the tab button and I've got access to all my columns here. So let's take a column like department, right? So what do people want to do when reporting, right? They want to Cool. So Zach, you already use DAX. Just out of curiosity, like what kind of things do you like to use DAX for? And in general, actually, just so for the other people who are on here, what are the kind of typical operations that you do with your data? And what kind of things do you do? Are you accountants or like statisticians, or what is it that you do with your data? All right. So I'm not too sure how many people on here were on the last kind of stream I did, but how many people here would be interested to see how you could basically generate a file or report for, say, every single one of these departments, right? So there's 31 departments here. Let's say you wanted to churn out a really quick report for all 31 of them. So if I nest this, then basically what I've done is for every single one of these departments, I've just created like a subtable, right, for every single one of these departments. So if I want to do individual analysis, like I've shown you before, right? Like I could do a summary on every single one of these individual tables, right? Where you could just as easily generate, say, a file or something instead, right? So I could do something like pmap, right? And I'm going to take function department data, and I'm going to write CSV, and I'm going to create a quick folder to put this in actually in. So I'm just in this folder here right now. I'm just going to create a folder called output so I don't flood this. Okay, right now this is empty. So here I'm going to say I'm going to write the data, and the file is going to be called so paste is just the command for concatenation, right? And I'm going to put this into output. Department .csv. Okay, so that's just on that, right? So you can see that's just generated these, what, 31 files in about a second. So okay, there you go. Cool. Now that I have shown you that, I just want to give you a little warning about this as well. So one of the reasons I like to share this function, it seems to be something that people quite often do. So we started this session with how to merge a whole bunch of files. And now here's how to split out all the files. So what are some of the reasons why people split files and merge them all back together again? Well, maybe you're doing some sort of data collection process, because one of the things that one of the things that Excel does, which R doesn't sort of really do, is that Excel contains formulas. It also contains the data, right? And so in some ways, Excel is also a data storage format. It's also a sort of data collection a method for collecting data as well. Now, what is the problem with collecting data in an Excel spreadsheet? Let's say you've just chopped up and you've just made 31 different files, and you send it off to a whole bunch of people to, input extra values into, make some corrections or whatever it is. What is the problem with that? Well, the problem is that people can very easily change and manipulate your files, right? And so you end up with, it leads to a lot of data quality issues. So it's probably worth mentioning a few things that, because here's the thing, right? When you start getting into data science, data analysis and everything like that, the number one thing that's going to take up 80-90% of your time is basically cleaning up data, right? So gluing it together, tidying it up. And the more that you can avoid, the more you can do to avoid data quality issues, the easier your life is going to be. So when you send out files, what do people do? They'll probably go, oh, save as. Maybe they'll make version 1, version 2, version 3. Now you've got, let's say you've one department has got 3 versions of the file. Well, which file is the right file, right? Is it which file has been submitted? Maybe if they submit 2 files, then you consolidate all your files and now your numbers have just doubled, right? So if you're not careful, you could very easily end up like skewing your data by doubling up the values, right? So there's all these kind of things that you just need to be really, really careful about there. And, you know, people, add extra columns for notes. They, shift things around. All kinds of things, right? They mess up the data types. And then all of a sudden, your stuff doesn't work anymore. So a few suggestions that you could use as alternative. I mean, obviously, if you are using Excel, there is things like data validation, right? So where's my copy of Excel? A little trick as well. So for instance, frequency, I've got hourly, daily and hourly, right? If I select the entire column like this inside a table, Alt-DL is shortcut for data validation. I could make that a list, and I could make that, I haven't done this in a while actually, hourly and daily. Then it affects all of the items, right? Even if you add more. So a little tip there. But even though I've just shown you this tip, I don't really recommend it because it's still not that robust, right? In comparison to other things. So if you're using something like a database, the column types are going to be much more enforced. Like I said at the beginning of this whole session, right? So Hinder dropping off now, so you have to leave. I'm going to wrap up shortly actually, but just a few more things to go. So if you are what was I saying? So yeah, the thing that I mentioned with Excel is that the data types aren't very well enforced. And this is probably the upside and downside of Excel, right? From a data analyst point of view, for collecting data, it is actually horrible, right? Because people can and will mess up your data very easily. Almost no matter how much you lock down your sheet, it's going to be, you're going to have issues, right? And if you lock your thing up so tight, you'll find that people can't maybe insert rows or something like that. They can't add data, all these kind of things, which just really makes your solution really inflexible, right? What are some of the other solutions? So I mentioned databases, but what's the problem with a database? Well, the problem with a database is unless you're the IT department, you're probably not going to be able to implement one, right? So other things that you can use, like if you're an organization that's using a Microsoft stack, then usually you can use something like SharePoint, right? Now, when I say SharePoint, I'm not talking about just a file sharing SharePoint, because that's not really a very good solution either, because that's basically still Excel, right? Just hosted on the SharePoint. I'm talking about SharePoint lists. So, and maybe I'll talk about that at another time if anybody finds that interesting. Other solutions, like if I wasn't stuck to the Microsoft stack, then I'd probably actually use Google Sheets. Now, what's the difference between Google Sheets, SharePoint, and Excel? The number one kind of key differentiation in this circumstance anyway is that both SharePoint lists and Google Sheets are centralized, right? So they'll handle version control, they'll handle record keeping, all that kind of stuff like that, right? Yeah, did I mention version control? Anyway, they'll handle all of those things for you, whereas Excel will not. It's a distributed system, and really, when you're doing data collection across for lots of different people, ideally you want a centralized solution instead of a distributed solution, right? So, it's anyways, I hope you guys found that helpful. I just wanted to really start a quick live stream today. Just haven't really done much teaching for the last month or so. So just wanted to get with Christmas and school holidays and everything like that. So I wanted to get something out for the new year. Hey, if you let me know what more you want in terms of training and everything. Try and get into a little bit more depth into a few things. I am working on some new courses for my data school at the moment, which is at www.datastrategywithjonathan.com. And so if you head over there, if you haven't signed up already, there's some free training course there. Other things that I'd like to kind of cover in the future. So today we didn't really talk that much about too much about things like Python. We didn't really talk about too many things like version control, things like reproducibility. These are all very, very important concepts for data analytics and data science. But I think I just kind of think in a way that for a lot of people, especially the people coming from the Excel kind of background, which was one of the kind of key things of the day, is just first of all, realizing that there are some other and alternative ways to doing some of the stuff that you currently do in Excel that make it a lot more powerful. And just by getting some of those things out of the way first and getting into the tools that will also expand into more data science-y kind of stuff, then you're going to be able to kind of get yourself ahead. But just even getting your everyday work done more efficiently as well is really going to help you out. So anyway, if you head over to my website and check that out, that would be cool. I am, like I said, I'm working on some courses. I have a little discount code, discount code for anybody who wants to check out some of the courses. Just type it down here. It's basically YouTube Live is the coupon code, right? So just for you guys today, as a special little gift, yes. This is when I kind of launch this course properly. It won't be so rambly like I am today. It's definitely going to be a lot more structured and have a whole bunch of structured video lectures with example files that you can download and all that kind of thing. So if you want to go check that out, that'd be cool. Just as another little kind of gift as well, for a handful of people, I'm going to be giving away a bunch of free personal coaching. Just so I can work with a few people one-on-one, find out what your problems are, and just, helping people to get ahead a little bit faster. Because I know sometimes when just watching videos and lectures and all this kind of stuff like that, sometimes it doesn't really help always answer like all of your questions directly. So for the first 5 people this year that sign up to school, I'm going to give away an hour of free coaching as well. So anyway, I hope that helps, and I will see you guys next time.